All right, today we are going to start with our 3.1 notes about slope. Reminder for these videos, if I am moving too quickly, you are welcome to pause and rewind at any time, but I will work them pretty quickly. Jerry has two hills near his house that he can choose from to go sledding. Each side view of the hill is given below. Compare the vertical distance or rise of each hill. So for this, we are looking at the up and down, that is our vertical distance. And you'll notice that the vertical distance has the same rise of 20 yards. Then B says compare the horizontal distance or run of each hill. The horizontal distance, goes side to side, just like this. And you'll notice that one of them have a horizontal distance. A has a horizontal distance of 30 yards, and hill B has a horizontal distance of 20 yards. Which hill is steeper? Explain your reasoning. Now, when we're talking about steeper, we're thinking about how hard would it be to climb this hill, right? Steepness is the slope of the hill. So when I'm looking at steepness, I notice that hill A is a little bit more gradual. Hill B is a little bit more up and down. So I would say hill B is steeper because it rises 20 yards over a shorter distance than hill A. So today we're talking about slope. On graphs of linear relationships, meaning a line, the slope describes the steepness of each line. Slope is the ratio of the vertical change to the horizontal change, or rise over run. Rise would be up and down, run would be side to side. Slope is also equal to the rate of change of the graph. So really important to remember, rate of change and slope are synonyms. They mean the same thing. So if you hear the word slope or you hear the word rate of change, they mean the same thing. All right, so it says review the 4 types of slope by labeling each graph at the right. Now, we always read a book left to right, okay? We read a graph the same way. So if our line looks like we would be biking up a hill, it's a positive slope. If our line looks like we'd be biking down a hill, that would be a negative slope. Now, if our line is just flat, it would take no effort at all to bike on that ground, so we have 0 slope. And if I have a vertical line, that means that it would be very challenging. It's like a cliff. I can't bike on that, so I would say it is undefined. Now, when we actually go to find the slope, we are focused on rise over run. So I'm thinking about the change of my y and the change of my x. So rise is my numerator, and run is my denominator, okay? So if I find 2 perfect points on the graph, like you see here, I have a point here at 3, 2, and I have a point here at 6, 4, then I need to focus on how many do I have to go up and how many do I have to go over to get to the next point. So I would start at my leftmost point, and I would go up 2, and then I would go over 3. So my rise is 2, my run is 3. Okay, rise over run. And I flipped my colors there, but you'll notice that I could erase this. Let me make it right. So red, I'm going to do rise, is up 2, and run is over 3. Okay, so 2 over 3 is my slope because that's my rise over run. Now, if I'm not given perfect points, I need to make perfect points. And what I mean is if you see a point that perfectly intersects on the coordinate grid, that would be considered a perfect point. So here are some two of my perfect points. I also need to be aware of my x and y axis. If they're jumping by the same amount, you can just count by ones. If they're jumping by different amounts, you need to be aware of that and make sure you're skip counting in order to calculate your rise and run. Now I'm still going to start at my leftmost number, and I'm going to go down 2, because this jumps by 2, and I'm going to go over 2, 4. Over 4. Notice I did -2 because I had to go down 2, and then I went over to the right 4. Now, -2/4 -2 over 4 is equivalent to -1/2. Okay, so that is the same thing. Therefore, my slope for this line would be -2/4, or more simplified would be -1/2. Now, when I look at number 3 and I'm thinking about rise over run, I could pick any two perfect points again, for example, and these are jumping by 2.5, so I'm going to skip a line and jump by 5s. So my rise would be down 5, 10, down 10, but I don't have to go over, so I'd go over 0. My run is 0. Now, -10 over 0, in my calculator, I cannot divide by 0. Nothing can be divided by 0, ever. So my answer would be undefined. So a vertical line has a slope of undefined because the run is 0 and I cannot divide by 0. All right, moving on to the back. Clark loads boxes of paper on a pallet before shipping them. The graph shows the linear relationship between the number of boxes of copy paper and the weight of the pallet. Find the rate of change. Okay, I'm going to go ahead and pause. Find the rate of change is the same thing as finding the slope. I want you to circle that and write slope next to it because we need to remember that those are synonyms of the pallet weight with respect to the number of boxes. So I still need my rise over my run. And right now, I'm going to pause and recognize that my y-axis jumps by 10 and my x-axis jumps by 1s. So when I'm counting my rise, I need to go 10, 20, and when I'm counting my run, I need to count my 1s. So my rise, I'd go up 10, 20, up 20, and my run would be 1, 2, 3, 4. So my rise was 20, my run was 4. And we can use our calculator to simplify this, but if you do, it's a +5. Now, I know this is positive because I had to go up, then right. And I can also tell you it's positive because I would be biking uphill. Okay, and this is just kind of a silly way that I remember. If I read left to right and I'd be biking uphill, it's positive. Okay, if it were going downhill, I'd be coasting, it would be a negative slope. All right, Lainey set up a lemonade stand. The graph below shows the amount of money in her cash register with respect to the number of customers Lainey has served. Find the rate of change. Now, when I recognize my x and y axis, I see they're both jumping by 1s. So I just have to place two perfect points. I see one here on my y-axis, and I see another one here at 4, 6. So I'm going to go up 1, 2, 3, and I'm going to go over 1, 2, 3, 4. My rise is 3, my run is 4. And this is a simplified fraction, so that is as simple as it gets. I cannot go any further. So the rate of change, or the slope of this line, is 3/4. Okay, a cold front hit Milwaukee, Wisconsin. I'm going to zoom in just a minute. And the graph shows the outside temperature with respect to the time passed in hours. Find the rate of change of temperature over time. Now, you're going to notice right now your brain should be thinking, this line looks a little bit different. It's going downhill. Therefore, I should have a negative slope. And you could put a little negative in your answer line just to remind you if you recognize that right away. You should also be checking your x and y axis. My x is jumping, my y is jumping by 5s. My x is jumping by 1s. So I'm going to place two perfect points. There's one right about here. And let's see, I see another one right about here. Okay, and that's where they perfectly hit the grid. And then I'm going to go down 5, 10, and over 1, 2, 3. So my slope would be -10 over 3. Now, when we're thinking about this and the context of this situation, I also should add labels, and I should have on the previous two as well, but I want to make this make sense. So if my rise is -10, that means my temperature is decreasing by 10 degrees every 3 hours. Now, it seems silly to say that, 10 degrees every 3 hours. So if we simplify and get a decimal, we would get negative 3.33333, continuing, but we'd round to 3.3 degrees per hour. And that little slash line just means per. So the temperature is decreasing at 3.3 degrees per hour. Let's go back to these other two and try to understand what that means. So my weight per number of boxes, if I'm looking at number 4, it's 5 pounds per box, because pounds is my numerator and boxes is my denominator. Okay, so it'd be 5 pounds per box. On number 5 with Lainey, it would be dollars per number of customers. Okay, and I'm just going to abbreviate. And I could also change this, because $3 for 4 customers doesn't really make sense. If I simplify, I get 75 cents per customer is the average amount. Okay, so that makes those word problems make a little more sense. All right, number 7, Jacob hopes to read at least 4 pages every 5 minutes in his sci-fi book. The graph shows the rate at which he reads. Did Jacob meet his goal? Explain. Okay, so he wants to read 4 pages every 5 minutes. So we're thinking 4 page over 5 minutes. And I know page is the numerator because that's my y, and then minutes is my x, and we do rise over run. Okay, so the goal is 4 pages every 5 minutes or more, right? That's his goal. So here's 2 perfect points. And you'll notice that both the y and the x-axis jump by 3. Excuse my colors. And so I'm going to be able to, because they jump by the same amount, I'm going to be able to just count by 1. So I'd go 1, 2, 3. So up 3 over 1, 2, 3, 4, 5. So his actual rate of change is 3 over 5. So he read 3 pages in 5 minutes. So we could say, no, he did not meet his goal. He only read 3 pages in 5 minutes. Better luck next time, right, Jacob? All right, let me make that so it's visible here. Excuse me, if it'll cooperate. And it's frozen. We love technology. All right, we're back to working, and I wrote the words up here. So no, he did not meet his goal. He only read 3 pages in 5 minutes. All right, the last one on this page, I'll have to jump below. 3 lines were graphed below. Use the information in the table to help fill in the missing rate of change and record the letter of each line that matches the situation. So we really just need to be thinking about positive or negative slope and steepness. So ignoring the table for a moment, I just want you to pay attention to the lines. Line A is downhill, so this is going to be a negative slope. Line B and line C are uphill, so these will both be positive slope. So when we evaluate our situations, we have saving, and spending. So right there, I can recognize that line A is my only spending, it's my only negative, and my rate of change would be spending $7 every week. So I could say negative $7 per week. Now, if we look at our savings, $11 every 3 weeks or $9 every 2 weeks, I can write it as a simplified fraction. So 11 divided by 3 equals 3.66 repeating. Okay, so we could say 6, 7. All right, and 9 divided by 2 is 4.5. So which one has the greater slope or would be increasing faster? We would say spending $9 every 2 weeks. So we would say $4.5 per week. Therefore, our steeper line, line B, would match with saving $9 every 2 weeks. Okay? The saving $11 every 3 weeks would be $3.67 per week. And it's more gradual savings, so that would be line C. All right, we are going to go on to the next page. And again, just a reminder, if you are needing to pause or rewind, you may. What is the difference, the change, in y values from S to t? So these are 2 points on a graph over here, S and t. And we're thinking about what's the change of the y values. So the difference, remember difference means subtract. Write yourself a little note. So if I do 9 minus 3, I get 6. This is my rise. What's the difference or change in x values? Well, that's 6 minus 2, which is 4. That's my run. So if we write this as a ratio, the change of y over the change of x, I would have 6 over 4. Now it says compare the ratio in part C to the ratio of rise over run. What do you notice? So now we need to actually evaluate our y over x. Our x and y axis both jump by 1, so I can just count by ones. 1, 2, 3, 4, 5, 6. Interesting. And 1, 2, 3, 4. So my rise over run is 6/4. And my ratio of change in y over change of x is 6/4. So they are the same. They are the same. Okay, so this describes our slope formula. We can describe the slope as the following ratios, either the rise over run or the change in y over change in x. Because of these ratios, we have a slope formula. It's y2 minus y1 over x2 minus x1. So my y values would be the change in y, or I can count up, and my x values are the change in x. I can count across. And this is great for if we have a graph that is not properly labeled, or we have decimals involved, we're not finding perfect points, or even if we just have a word problem that describes the change in x and the change in y. So let's look at a few examples. When we're looking at these examples, please remember that you can use any of the x and y values. Choose the ones that are easiest for you. So I'm going to be looking at my y values, 11 and 3. So I'm going to do y2 minus y1. And I want to go 11 minus 3 because 11 is larger, so I'm not going to get a negative number. But if I start with 11, I need to also start with 1, the correlating x value, minus 0. So this would simplify to 8 over 1. So rise over run, which would simplify to 8. I'm going to do the same with number 2, and I don't really have options. I can choose either of my y values to start. I'm going to call this y1 and this y2, but then that means that 3 needs to be x1 and -7 needs to be x2. And labeling it helps you keep organized. Because remember, our formula is y2 minus y1 over x2 minus x1. Okay, so we're going to take and do -3 minus y1, which is -4. So yeah, we're going to have a minus -4. And then that's over x2, which is -7, minus x1, which is 3. So yes, we have a minus negative, but remember that's just adding. So -3 plus 4 would be 1. -7 minus 3 is -10. So my slope would simplify to -1/10. Number 3, I'm simply going to choose the ones that have no decimals. So I'm going to say that this is my y2, this is my y1, which means 4 is my x2 and 0 is my x1. Okay? So y2 is -8 minus y1, which is minus a negative again. That's okay. And then x2 is 4 minus x1 is 0. When we simplify, these are a plus, so we have 3 over 4. So our slope is 3/4. And finally, it says a line that passes through the origin. You guys have been great with origin. Origin is 0, 0. So again, I'm going to label my y2. Actually, let me do these as my x1, y1, and x2, y2. So I'm going to do y2 minus y1, so 7 minus 0 over x2, which is 6, minus x1, which is 0. That's a really easy math, and it just simplifies to 7/6. So our slope is 7/6. All right, see where we're at on time. Perfect, we have about 9 more minutes. Okay, a graphed line contains the points shown in the table. What is the slope of the line? Again, y1 minus y2. We're going to say this is our y2, y1, and I misspoke. It's y2 minus y1 over x2 minus x1. Okay, so we have 710 minus 360 over 20, I meant to switch that to red, 20 minus 10. And you can just put all of this in your calculator. You'd get 350 over 10, which simplifies to 35. And again, we don't have context here, so we don't need to label it. Our slope is just 35. A graphed line contains the points 5, -9, and 5, 2. Find the slope and describe what that graph would look like. So y2, y1, x2, x1. Okay, so I'm just going to switch to purple here. So I have y2, which is 2, minus y1, which is -9. So minus a negative, that's okay. Y1 is 5. Make sure this is a clear 1. And x1 is also 5. Interesting. So that gives me a denominator of 0, no matter what the numerator is, which is 11. If I have 11 over 0, my line is undefined. And I know it because I could type it in my calculator. And if we look back at our notes, this would describe a vertical line. The slope is undefined. It's a cliff. We cannot bike on it. Tropical Storm Ava brought heavy rain to Galveston. The table shows the linear relationship between the total inches of rainfall and the time in hours. Calculate the rate of change, which is slope, of the rainfall per hour. That gives us a little hint. Our rainfall is our y because it's our numerator. Our hour is our x. So again, I'm just going to choose my whole numbers. So 18 minus 9, 24 minus 12. And I have to choose my correlating x values if I choose my y. Okay. Now, if I plug this into my calculator, I get 9 over 12, which simplifies to 3/4. Now, to say 3 inches of rain in 4 hours seems kind of silly, so this would be appropriate to switch to a decimal. So we'd have 0.75 inches per hour. Now, Chrissy made a mistake when calculating the slope of the line that passes through the points -18, -5, and -4, -1. Describe Chrissy's error and then correctly find the slope of that line. All right, now, when we're looking at this, I'm just going to go ahead and label. It looks like she started with -1. So I'm going to say that this is my y2. That means that -5 is my y1. And that means that negative 4 is my x2 and negative 18 is my x1. And I just chose that based on her very first number. Okay? So she would be doing negative 1 minus negative 5. Now, she writes plus, but that's okay because minus and negative would be adding. And then you may notice her mistake. She should have negative 4 minus negative 18, but she accidentally flipped these terms. So she accidentally did x1 minus x2 on the bottom. So I would say Chrissy flipped the x2 and x1 in the denominator. So we've started to figure out, not typing very well, excuse me, ignore my misspelling there. We've started to figure this problem out, and we did decide that her numerator was correct. She was good with the 4, but then negative 4 minus negative 18 would be negative 4 plus 18, which would be a positive 14. 4 over 14 would simplify to 1. No, it doesn't simplify to 1/7, it would simplify to 2/7. So the correct slope would be 2/7. All right, we're just about out of time here, so I'm going to do one more with you. At least one more, I guess. Marco is growing crystals for an experiment. He has 2 jars containing different solutions to form the crystals. The tables show the linear relationship between the amount of crystal growth in grams and the number of days that have passed. Which jar has a greater rate of change? So think greater slope. We're just going to have to use calculations here. So I'm going to go ahead and use, let's see, it's grams and the number of days. So grams must be my independent. So I'm going to use these two, or my dependent, excuse me, and the days are my independent. So I'm going to say 43.5 minus 29 over 6 minus 4. Now you can control, I'm going to just write this down, control divide to get your numerator denominator, your fraction bar, and that would simplify to 7.25. So that's 7.25 grams per day. And then jar B, we're going to do 37 and 22.2 because you don't have to use only whole numbers, but it just helps. So let me show you. 37 minus 22.2, and then 5 minus 3. And again, this simplifies to 7.4 grams per day. So you should say jar B has a greater rate of change because 7.4 is greater than 7.25. And you can explain by saying the grams increase more per day than jar A. Last one we're going to look at, use the graph to answer A through C. Explain the method you would choose to find the slope of the line. Because I see a decimal, I would use slope formula. So I would do y2 minus y1 over x2 minus x1. Okay, 7.5 or 7 minus 4.5 would be negative 2.5 over negative 5, which would reduce to, oh, excuse me, it'd be positive 2.5 over negative 5, which would reduce to negative 1/2. This would be, the slope formula would be more helpful than rise over run because there is a decimal. So counting rise over run would make less sense. All right, if you have any questions, please ask your teacher. That is the end of our 3.1 notes.